All right, so object-oriented programming. So this is our third paradigm. And this one's substantially different than the other two. So I know some of you have taken to this pretty quickly. Some of you are going to have a harder time with this. Come on. So we just did a bunch of procedural stuff. What's procedural programming all about?
Oh, you muted yourself.
Come on. What's procedural programming?
Telling the computer exactly what you want it to do.
Yep. Okay, so what's functional programming? It's a little trickier. This is
JavaScript?
not necessarily. We can do OO stuff. We can do procedural stuff in
yeah.
JavaScript. So this is describe how inputs become outputs. So you might remember when we were doing a lot of functional programming, the map and the filter and the reduce and the find and stuff, we did a lot less saving things in variables and iteration and if statements. Like instead of an if statement, we would filter out something that we didn't want to process and then map over whatever we had left. So very different from procedural programming. We describe the transformation that we're doing in an abstract way. This would turn any input that's the right shape into any output that's the right shape. A chain of processes. That's functional programming. OOP, I'm going to call this code is written in terms of how nouns verb each other. So we try to model things with these things called objects, and then we model the behavior of our program as those objects sending each other messages. That's kind of the heart of OOP. So the guy that came up with OOP is a guy named Alan Kay in the 60s. And his favorite metaphor for this was cells in your body. So we have all these cells, and each one of them is self-contained, and it's got its own nucleus, and it's got its own ribosomes, and it's got its own cytoplasm. And so it encapsulates its own state, and it can also send little chemicals to other cells and if we have enough of those doing all of that, we have people, we have life. And all of them come down to these little bags of goo that send each other messages. That's object-oriented programming. Building blocks of object-oriented programming. Classes, objects, constructors, properties, methods, interfaces, that's a pretty good start. All of these things are specific to OOP. Sometimes we use like some of these terms in other places, but all of these are OO ideas. Now, a lot of you have been doing some reading. Let's take classes as an example. Who can tell me what a class is?
I've always thought of a class as being like a cookie cutter in a way.
Love it.
It's like it's the shape of the thing.
Yes. It's a cookie cutter. So if that's the cookie cutter, we can use that to make plain cookies. We can use it to make cookies with sprinkles. We can use it to make butter cookies. We can use it to make all kinds of different stuff. They also have the same shape. They're also cookies. But they can have some things that are different about them. So the little like machine that cranks out new cookies, new objects, is a class. Another metaphor you could use for that, it's a blueprint. By the way, neither of those are perfect metaphors. If you hang on to them too hard, it'll hurt you at some point. Totally fine place to get started with it, but that metaphor does break down kind of quick the more you work with classes. So ultimately, they're their own thing, but philosophically, this is what they do. Questions about classes? To make a class in JavaScript or TypeScript, we use the class keyword. We open up braces. Class is just like classes are just like functions. They're declarations, so they hoist. They're not statements. They're not expressions. It's their own thing.
A class usually describes the contents of the objects that belong to it, right?
It describes how you make one of those objects.
Okay.
So after they're made, they kind of don't need the class anymore. You can add stuff to an object that wasn't on its class originally. 99% of the time, though, yes. It's instructions on how to build the stuff, so that's where all that's getting defined. Classes. So if classes are the cookie cutter, objects are the cookie. So an object is also called an instance. That's something that was made with a class. So you can say things like, what's the class of that object? If that sounds a lot like saying what's the type of that variable, it's because it's the exact same thing. A class is a type. An object is like what actually does the work. You can't eat a cookie cutter. You can eat the cookies that you make with it, though. Theoretical, actual. Describes how you make something, is the thing that you make. All right, I'm going to use this this JS, or this the parcel thing from the last lesson. Make some code. So if I go, let's see, I'm going to make a source and a OP lesson TS file. Okay, so that defines a class. That's an object. We make new instances with the new keyword. You've seen that a couple times before. We saw that with date, handful of other things. URL search params. You might notice too, class is Pascal cased. Capital S, capital C. Hey, just like new date or new URL search params. Anything that's a class starts with a capital letter. The objects that you make with the class work the same way as every other value in JavaScript. That's also coincidentally why types are capitalized. A class and a type are effectively the same kind of thing. We can't make things with just a type alias like we can with classes. They serve a similar function, though. Questions about objects?
So for example, if I was doing a class of dogs, then my objects would be like breed, size, age, that kind of thing?
No. Great question, though. So if we did something like this, and I was instantiating those, I wouldn't have like that. What I would do instead is have a class called dog, singular, and then I would make specific dogs with those.
I like this would have made Gilded Rose much easier.
Maybe. There's like a lot of, and this is like a very common criticism of OOP. There are some problems that are way easier to solve with OOP, and there are other ones that are like way harder. Gilded Rose, maybe. I'd buy that. Because like you could have like a product type, and you could have more specific products that like have those rules and stuff to them, and each one of them could have a depreciate method that implements it a little bit differently. Yeah, I'd buy that.
Too little, too late now.
It's a kata. You're supposed to do it a billion fucking times. That's not the last time you're going to do Gilded Rose in your career. Promise you that. But yeah, it's describing the type of something. Object is the actual thing. But Bixby and Harmony and Rex all have the same shape. They're all dogs. They all have legs. They all have a bark method. They all have whatever. So instead, breed would be a property of dog.
So if you added a property of like you did your example in our lesson, if you did a property of number of legs or something like that, and it was 4, then like Bixby and Harmony and Rex, they would also carry over that property.
Correct. So if I do
Okay.
Bixby dot number of legs, that's 4. Other questions about the relationship between classes and objects? Constructors. The job of a constructor is to put the object in a valid state. It's kind of a pretentious way of saying, make it work, set it up. The constructor is what you call when you use this new keyword. So like, it's called constructor, lowercase c, always. And it takes arguments. I could say this takes a breed, and now all of these are mad that I didn't give it a breed. Bixby was a Chow German Shepherd mix. Harmony is my favorite kind of dog. I don't know. I don't know what kind of dog Rex is. So I can do all of like my normal, like JavaScript-y kind of stuff. And say, all right, defaults to mutt. And since I gave it a default parameter, it also can infer the type now. So it's very common in a constructor to take things in like you do with a function, like this, and then just set them on the instance. It goes, hey, I don't have a breed. So I can say breed is a string. Now it's not mad at me anymore.
I have a question.
Yeah.
So when you're a constructor, like every property, you have to pass it as a parameter. But what if you have like 8 properties?
Sure. So you got a couple options there. We could do something like dog attributes. Well, a dog has a name. It has a age. It has a breed. It has whatever the other things that we want to initialize are. If you have more than like 2 or 3, it's pretty normal to put these in an object. And then this becomes like we destructure it out. and then give it the type of dog attributes. So then we have name, age, breed, whatever. Like that. And then now these are mad because I'm passing in strings. So I can say name, oops, say name is Bixby. So now, if I pass those in instead, name is string, age is a number. Now it works.
So then you could also do like an array of objects too if you wanted to, right? And just wrap it in a big or let.
Done. I can even type annotate it. This is an array of dog objects. Constructors. Take something in, add them to the object. That's what the this keyword does. That's saying on any particular dog, set its breed to this, set its name to this, set its age to this. And so I can do like Bixby.breed and get that long thing. I can get Bixby.age and it's 12. I can do Bixby.name and it's the string capital B Bixby. Like that. Yeah, if you have to pass in a bunch of things to set it up, probably put those in an object. Now, also keep in mind, it's not a rule that you have to give every single thing that you could possibly imagine the dog having in the constructor. It just needs to be in a valid state. I don't know, maybe you make a new dog and you don't know its name yet. All right, well then it doesn't need the name to exist. But maybe it's a rule that a dog has to have a breed or it doesn't work. That's the kind of stuff that goes in a constructor. Stuff that needs to exist for it to work. Because you can also say, all right, all it needs is this. It can have those other things. And now like TypeScript is mad because it's saying like, all right, you're saying that these things exist, but you didn't initialize them. So you can get around that by going like, all right, I don't know what the name is yet. What's the age? 0 until I say otherwise. Then we update these.
In this case, would the constructor be the child and the dog class be the parent?
Say that again?
In this case, I remember reading about it briefly on the OOP about the child and the parent.
Mm-hmm.
Would this be considered the constructor, would that be considered a child of the class dog?
No. Great question, though. So we say that Bixby is an instance of the dog class. That parent-child thing has to do with something called inheritance. So I could make a more specific kind of dog called like German Shepherd. And I can say that it extends dog. Just a sec, my kid just came home. Yeah. All right, so this German Shepherd class is going to have everything that dog has plus whatever else we want it to have. So I don't know, maybe German Shepherds have like a is police trained property to them. Now, if I make a German Shepherd out of Bixby, Bixby has a number of legs property. Bixby also has an is police trained property, because Bixby is a more specific kind of dog. That's the parent-child relationship. So you'd say that a German Shepherd is a subclass of dog.
You're currently feeding in the dog's names as their breed.
Oh, good call.
So where does scope come into play in like encapsulation?
Great question. So encapsulation, this idea is a little bit different. Like, so the stuff in the OOP reading is OOP in general. JavaScript and TypeScript are still a teeny tiny bit fast and loose on this. So the idea of encapsulation is that maybe it's that and that's. So when I do something like Bixby.name, that's technically direct property access. That's not how you would do it in Java. It's not how you do it in Ruby. It's how pretty much everybody does it in JavaScript and TypeScript. And this was actually in the queue earlier today. You can also do stuff like this, where you say, all right, name is get name, and then you can make that a function that returns this dot name. Now we need a setter for it. This dot name equals name. Okay, so that's encapsulation. And so I can still do Bixby.name, but I'm not actually getting Bixby's name directly. I'm getting it via this function. That's encapsulation. But like the big idea on encapsulation, the important thing to know about it is this cells idea. One cell can't actually see inside of another cell. That cell can send a message that's like, oh, by the way, this is what's inside of me. It's a very like, almost like a semantic distinction, but that's encapsulation, is that you don't actually see what's inside the object directly. It's always like mediated by these functions. Now, in practice, this, it's just a shorthand for that. Like, that's the exact same thing. So that's what most people do if it's something simple like that. Scope works like, I don't know, kind of like it does most places. So you can have, like, if I have some variable out here.
May I interrupt you, Kyle?
Sure.
Shouldn't you have a semicolon after your empty quotations for name and also age in your class?
Automatic semicolon insertion. So, like,
Okay.
style-wise, those should be consistent, but they're not required,
Okay.
just like they're not required anywhere in JavaScript.
All right. Thank you.
Good eye, though, because they are required in Java. Like, that would be a compile time error in Java because it's missing the semicolon. Good eye, Tiffany. All right, so this is out of scope. Or sorry, it is in an outer scope. I can still access it in here. It's the same like inner scopes can see outer scopes kind of idea. But like within methods in a class, it's a lot of like using these kinds of things as like a communication way finding thing. You refer to things like on the instance with this to kind of handle how those things communicate inside of an object.
Kyle, is it too outrageous to say that this really looks like the building blocks for an API?
Like it could be. So like here's some examples. Rails is like a pure object-oriented like API framework. So what you tend to have in like a Rails API is you'd have like a dog model that looks like exactly like the one that that we just did. And you go, okay, I want to serve that up in an API. And so you would do something like you'd have a controller class, the instance of which is like attached to a /dogs route. So whenever that happens, we call the like dogs controller that is a subclass of controller. And then that dogs controller has a method called get. And when you call that method, it creates an array of dog instances that it like pulled out of a database or something like that. And then there's a response class that has a subclass called JSON response. And JSON response takes an array of dog objects and turns them into a JSON string and then sends that back to you. So that's how we would use this kind of idea in an API.
Okay, cool.
The thing that I think is that like object-oriented programming is like world beating at is coming up with models that like represent concrete things and giving us like really convenient ways of working with them. Kicks ass at that. I think it's a little bit less good at this like controller, response object, JSON. That gets a little bit more dicey, but yeah. What else we got? Properties and methods. Outside of an object, it's called a variable. Inside of an object, it's called a property. Outside of a object, it's called a procedure. or a function inside of an object, it's called a method. They otherwise work the same way. Property, 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 property. Method. Method. So I could do something like bixby.bark, and that's going to log woof. Let's see. I don't want to go too far down this rabbit hole, but something that TypeScript offers is the idea of what we call access modifiers. Hi, Miles. So an access modifier is who is allowed to read this property or call this method. So that's normal. You can also say private, and now that doesn't work. See, it's already mad at me. Property bark is private and only accessible within the class dog. So I could have a public method called getMad that just does this.bark over and over again. That's allowed. And I can do getMad. I can call bark that way. If it's private, it can only get called by something that was defined inside this class. You can't call it outside.
What would be the purpose for that?
Oh,
Like, why would...
Brad! Thank you for the easy alley-oop on that. The exact same reason that we use types for safety. So if I have something that is like an internal only, like even within a class, it's still normal to break something up into like teeny tiny pieces. Not all of those are part of like being a dog. Some of those are just random utilities that we happen to be using. So like, let's say there's like a, I don't know, like a 2 uppercase method or something in here. Or we've broken up something that's one big thing into 3 discrete steps. It's pretty normal to make all of those little steps private so that you don't accidentally call them. The only reason they're there is for whatever public thing is there. And the problem is if you start calling it outside of there and you go, oh, this big complicated thing, I found a different way to do it. You start changing it and then all your code breaks because you started depending on things that weren't actually part of being a dog. So TLDR on that.
Could you use it to like target like how you're marketing to a person like based on their age or anything that may have been entered at some point, or would that be too far out?
Not necessarily that. It's more like, is this an implementation detail? Is this something that only happens inside of the cell? Or is it something that like other cells need access to or should be able to call or whatever else? Is it part of their interface? So like another way to think of this might be if I have a jukebox, you think about, all right, what kinds of properties and methods might a jukebox have? Well, it might have like a
music.
Currently playing song. something like that. It might also have a list of songs. It could have like
A queue for whatever's next.
those things. Remember the things that like flip pages? As like I don't know whatever.
The next song feature.
Like something like that. It's like pages.
Well, yeah, it was like so you could flip through and find songs.
Right. Exactly. So you might also go, all right, well, what things am I allowed to do? I'm allowed to pay. I'm allowed to select a song. And maybe that's it. All I can do is pay and select a song. There might be other methods inside Jukebox, like, for example, a stop method. Well, the user doesn't get to do that, but it might be part of selecting a song. If you pay and select a song, it interrupts whatever song is playing. And so that calls a private method called stop, but the user doesn't call that directly. It's not part of the interface of the Jukebox. It's part of the implementation detail of the Jukebox. We might also use all kinds of other properties that like represent all these like intermediate states and stuff that the user doesn't access directly. All the user does is know what's currently playing, see what the songs are, see the pages or whatever. The things they can do, they can pay, they can pick a song, they can flip pages or whatever. Everything else, the user shouldn't be able to do. That would be the equivalent of like, well, the user can open up the Jukebox and just start moving around the like gears and stuff inside. We don't want to let them do that. We want a neatly defined interface about how that works.
So all the methods that make it work will be private, and then just the public will be what they can touch. But it may call on 4 or 5 different private ones to actually make it happen.
Ding, 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 ding. That's exactly it. Our public methods define what we want to allow the other cells to do to us. Private methods are our own business. That's how we get all that work done, but they don't get to call any of that directly. So this cell can go, here's some money, play a song, change the page. It can't go, change the songs that are available in the thing or whatever. It can't go like reorder the pages. It can't go stop. That's just not something it's listening for. That's private and public. Now, what's cool about this idea of interfaces, we can actually write the interface before we write any of this code. We can do exactly what we just did. All right, what should a Jukebox be able to do? All right, those are the public methods. You could write that as an interface. You could say, well, there's a interface called Jukebox, and it has a currently playing property that's a song. It has a pay method that takes in money and plays it. No, it shouldn't be that. I think it's mad at me because like none of these actually exist. Oh, integer. Come on, dude. Who raised you? Wrong language. Select song. That might be like the song name, and it changes the state or whatever. All right, so that's our Jukebox interface. Or sometimes you'll see people do this. They'll put an I in front of that. I could make a class called like Golden Oldies Jukebox implements Jukebox. And now this, I'm getting a helpful error. Incorrectly implements the Jukebox interface. It's missing currently playing, pay, and select song. So this is like a type. In fact, spoiler alert, that and that are the same thing. Pretty cool. But interface is the OOP term for that. That type alias, that's the functional way of doing that same thing. So we have this interface. I might have 18 different kinds of jukebox. I might have like radio jukebox, car jukebox, standalone jukebox. But I can say something that every single jukebox has and can do. And then if I need to write code that uses a jukebox, just look at this part. Anything that uses that interface will work. That's the purpose of an interface. Confidence. Safety. Types. It's a static type.
Could you also include like an extends off of that too? So like Golden Oldies Jukebox implements Jukebox, and then extends off for something else.
Totally. So it can also it can implement more than one interface. You could have like it implements Jukebox, machine, and physical object or whatever. So yeah, you can have more than one of those. When you but notice that none of these actually have an implementation. This isn't actually a function. It describes the shape of a function, but it's not a function. When you inherit from something, you'd have like a base jukebox. And you could say that that has, maybe that is the thing that, let's see. Maybe that has the actual implementation for select song or whatever. And then our Golden Oldies Jukebox implements the Jukebox interface and extends base Jukebox. And so now, did I put that in the wrong place? Must proceed. There we go. So now this one has a select song. And see, it's even took it out of my error. So you inherit from something and you get its properties and methods. You implement an interface and you're being held accountable for implementing all the things in that interface. Similar kinds of ideas, and like you use them both. You can only inherit from one thing. You can implement as many interfaces as you want.
And does it have to use all of those if you implement it? Okay.
And like, so what that does is if I'm writing code that uses a jukebox, I am guaranteed that it will have this property and these two methods. So that means I can safely call .pay or .select song, and it can't break because the interface guaranteed that they gave me an implementation for that. Classes, cookie cutter. Object, cookie. Constructor, what do we need to like get this thing started so that it doesn't break? We can change the properties, we can call methods, we can do all that stuff down the road. But when I actually make an instance of this, what's required for it to be a valid instance? Properties and methods, variables and functions. Interfaces. What shape is this class guaranteed to have? What's the type, I guess, of the class? Nouns that verb each other. So, how far deep you need to go with this? OO is a whole thing. You're going to spend years, like, kind of wrapping your head around OOP. Stuff that, like, by the time you leave this program, you should be pretty solid on. All of these words. Class, object, constructor, property, method, interface. If you know those things and, like, have a good mental model for what those are, that's pretty good. If you know how to write about this much like class and object code by the end of the program, that's pretty good. Angular is all like OO based. One of the reasons that we're doing this. Java is strictly OO. You can't write procedural Java code. You can't write functional Java code. Everything is objects and classes and interfaces and stuff. So when we do, we'll revisit all of these ideas when we get to Java, and you'll see them in a slightly different, slightly meaner context. Java's a jerk. TypeScript is super like friendly and helpful and doesn't make you work that hard. Java kind of sucks. Like I was in a job interview once, and I had to. So Java class method, you have to write every single part of every single thing out. So I'd have like some class, and in the interview, they're like, all right, write a method that does this. And I was like, all right, it is a public static integer that takes in name, a private name that's a string, and then like, 4 other things like that. Before I know it, I'm like 5 things deep. This thing's 120 lines long in the signature. And I'm like, all right, I'm missing something. I know I'm missing something. What am I missing? And the guy who was interviewing me was like, you didn't give it a name. And it's like, it's that easy to lose that kind of stuff in there. So like, this is actually super good training wheels for us. But like, that 4 pillar stuff, you're not like, I think, gonna all the way get what polymorphism is all about after 16 weeks. I've never seen it happen, so I don't know why any of us would be the first on that. But if you can write about this much class-based code by the end of the program, if you have a pretty decent handle on these ideas, I think you're in good shape. Cool. Any last questions before we break?
For the classes object one, just real quick, if we could use the example for the dog that you already have listed out here in the code.
Yeah, totally.
So I have a dog named Clyde who has 3.5 legs.
Okay.
And he doesn't bark, or when he barks, he yelps.
Okay.
So would we be able to just see an object created with those conditions?
So there's a couple different ways we could do that. One is you could say, all right, so that's a dog. I'm going to make a subclass called Fussy Dog. And it's going to extend dog. And I'm going to override number of legs to be 3.5. And I'm going to override, I can't actually override bark sort of interesting. You'll see it gets mad at me. Because it's private. Only goes in that class. Now what I could do is make it protected. That'll work the same way. And I go, all right, I want to override that. And I can say Clyde is a new fussy dog named Clyde. Is it going to get mad at me about the constructor? No. Cool.
Okay. And now, so for the object that exists that's Clyde, how is it that we would assign a breed? Would it be Clyde.breed equals blue healer?
Done.
I see. Okay, cool. Thank you so much. That makes much more sense.
Could you have also added that information to the class of fussy dog if you wanted to?
Yeah. So I can say every fussy dog is a blue healer.
Right.
And so and that's why you would do that. I can also take both of those out and say Clyde dot number of legs equals 3.5. If you put something in the class like that, you're saying that like that's a default. If a fussy dog doesn't necessarily like default to having 3.5 legs, that's probably not where you would how you would initialize that then.
No, because that's special to Clyde's case or this object's case.
Totally. And so like this isn't that weird to initialize something with new and then set some properties on it. And that's actually crazy common in Java. Because like our constructor is just, I got to make a legal dog. It may not be a dog that has all the things that I want it to have yet, but can it bark without throwing a runtime error? That kind of thing. More questions about this?
And when you fill out, if you have a class with all of those properties on it, you don't actually have to construct it with each of those properties, right? You can do it with one or two of them.
Yep.
Okay.
So the constructor, like we're trying to get the object into a valid state. If the class needs me to give it more information to do that, like, like for example, it doesn't necessarily initialize to 4 legs, for example. But it has this bark method that says like, woof, I have this dot legs, or what was it called? Leg count? Number of legs. Okay, so if I do that, I can now initialize this into an illegal state. Because if I make Clyde and then I call Clyde.bark, that's a runtime error. Because it'll do this and go, there's no property called number of legs. So to make that safer, I either need to initialize the number of legs here. Now it's not a problem. Or here. Either one doesn't make a huge difference which. If it should be configurable, then you tend to pass it into the constructor. Otherwise, you can just put it directly into the thing. And now it's very helpfully telling me that I'm initializing Clyde wrong. And now Clyde can safely bark. Because if I call that method, I'm not accidentally going to cause a runtime error because there is no this dot number of legs property.
And in this instance, when you call it, would it say number of legs is 4 or number of legs is 3.5 because of line 42?
There it would be 4. Here it would be 3.5. Or no, here it would, actually in both of these, since I overrode it, it would be Yelp on both of them.
Oh.
Because I overrode the behavior. I said that one is going to be, woof, I have this number of legs. But a fussy dog, they're a little bit special. So we changed the behavior on that. That's polymorphism. More questions, more things you want to see. Go once, go twice. Cool. Well, I hope that helps. I hope that helps. By and large, y'all have been doing very well on the OO work that I've seen so far. I think you've been well prepared for this. Also, like, I'm going to put her on blast a little bit. Tiffany is extremely good at this. Tiffany has like crazy good OO instincts. So when you guys like put together a study group to work through those exercises or something, put her in charge. She gets it. Cool. I'm going to say we can keep hanging out here for a sec. Let's take another 5 minutes or so, and then we'll get into end of day stuff.